Hi, Mrs. Greathouse here. We are going to work on section 2.2 in chemistry. It's all about mixtures. Our goal is to know two different types of mixtures as well as how to separate them. So let's define mixture. A mixture is a physical blend of two or more components. Okay, when we make a mixture, there is no chemical change. Things are going to keep their identity. Like if we made a salad from the salad bar, we would mix up some lettuce and some cucumbers and some carrots, okay, and have a great salad. And we would still be able to identify the lettuce and the cucumbers and the carrots. Here's our key point. Based on the distribution of their components, mixtures can be classified as heterogeneous mixtures or as homogeneous mixtures. Okay, these prefixes hetero and homo should look familiar from biology. Do you remember heterozygous alleles that were different? A capital letter and a lowercase letter? It's going to have the same meaning here. It's going to mean different. Okay, do you remember homozygous alleles? They would be the same, either both lowercase or both uppercase. Okay, so those are our two types of mixtures, heterogeneous or homogeneous. Okay, so a mixture in which the composition is not uniform throughout is a heterogeneous mixture. It's different. It's got some differences in it. Our example of this is our tossed salad. Okay, we could still find the carrots and the cucumbers and the lettuce. Okay, trail mix is another example of this. You can see you have peanuts and raisins and chocolate chips and candy in your trail mix. In Lucky Charms, you've got the stars, the hearts, the clovers, and the cereal part, another heterogeneous mixture. Okay, what are the heterogeneous parts of chicken noodle soup? Okay, you might see chicken and noodles and broth, carrots and celery. Okay, so a heterogeneous mixture is one that is not the same all throughout. Okay, so what's a homogeneous mixture? This is a mixture in which the composition is uniform throughout. It's the same all the way through, just like you wear uniforms to look all the same. Okay, the homogeneous mixture is the same all throughout as well. Okay, our examples here include stainless steel. Okay, stainless steel is made of iron, chromium, and nickel. Okay, but when we look at a stainless steel fridge or a stainless steel oven, we can't pick out the iron and the chromium and the nickel. It's all smooth. It looks all the same. Okay, same with pop. Okay, pop is made out of mostly corn syrup, flavorings, colorings, but it's all mixed together, the same all throughout. None of those things would you be able to separate out. Okay, air is a homogeneous mixture of mostly nitrogen and oxygen. Okay, it's going to be the same all throughout. Homogenized milk. Okay, the fat and the protein parts of milk don't separate when they're put through the homogenization process. Okay, so we have a homogeneous mixture with milk. Okay, another name for a homogeneous mixture is a solution. Okay, stainless steel, pop, air, homogenized milk can all be considered solutions. The term phase is used to describe any part of a sample with uniform composition and properties. Okay, so our homogeneous mixtures have one phase, but if we talk about a heterogeneous mixture, it's going to have two or more phases. Okay, our example here is oil and vinegar when you go to make salad dressing. Okay, your olive oil all by itself, okay, that's one phase, it's homogeneous. Okay, your vinegar as well is one phase, homogeneous, but when we mix them together, okay, the oil is going to float on top of the vinegar, and we have two phases in this heterogeneous mixture. Differences in physical properties can be used to separate mixtures. Okay, I remember when I was little and my mom would make beef stew. Okay, I wouldn't eat it if it was all mixed up. So I would ask my mom to sort it out by color. Okay, so she'd put all the beef in one pile and all the potatoes in another pile and all the carrots in another pile, and then I would eat it. Okay, so she used the physical property of color. She would use the physical property of color to sort out my stew so I would eat it. Okay, filtration is one way that we can separate a liquid and a solid that makes up a heterogeneous mixture. Okay, just like when you cook macaroni. Okay, you've got it cooking on the stove in the hot water, and when it's done, you want to separate the liquid from the solid. So you use a colander to separate that. Okay, you pour everything into the colander. Okay, the water pours out the holes, and you are left with the pasta that you want to eat in the colander. That's an example of filtration. Okay, we can use this in the lab with a funnel and filter paper to catch the solids and let the liquids go through. Okay, coffee filters work the same way. Okay, the coffee grounds stay in the filter, and the water that's flavored with the coffee goes into the coffee pot. Okay, so another process that we can use to separate a mixture is distillation. Okay, during distillation, a liquid is boiled to produce a vapor that is then condensed into a liquid. Okay, and what's going on in this picture is that they are distilling tap water. Okay, in the tap water is chlorine to kill the bacteria and keep it safe for you. There's also fluoride in the tap water to help keep your teeth healthy. Okay, so what's gonna happen is okay, so during distillation of the tap water down here, okay, we're going to heat it with the flame, and it's going to turn into water vapor. That water vapor is going to rise. Okay, the water vapor is going to go through the condenser where it's cooled off because there's cold water going in around that. Okay, and it's going to turn back into liquid form and be collected in this flask here. This is going to be our distilled water. Okay, what's going to stay back here is the chlorine and the fluorine particles. And actually, when the process is all done, there will be a white film on the bottom of your glass that is a residue of everything that was added to the water. Okay, so you should have taken notes on this video and written down one question for me. Okay, now it's time to summarize. Our big points today were that we know two types of mixtures, okay, heterogeneous and homogeneous, and we know two processes to separate these mixtures: filtration and distillation. Thanks for listening. See you in class tomorrow.